She's in my business. She's driving.
Yeah.
Flips is he. On top. Could be either. We call that, but it's like, yeah, they go.
I was finishing the project, I was doing everything on the PowerPoints, and then I couldn't figure out what to put the answer into the equation. Because I like clicked on the y-intercept, not the y-intercept, but the set intercept. And then the equation like changed, but then it hurt my brain, and then my brain hurt my brain, when it hurt my brain.
Equation is given.
Yeah, then I should. Well, after class.
It's like one right there. So they're girls. I'm like just so funny.
Just like somebody.
And my dad has a shorts and
Finish your album.
no, I think it's this.
You're still on that.
It's not. And it's like,
So I'm saying, like, I don't know what to do. It's such one.
I'm sorry, my wasn't. Well, it's only look over and I'm like. Usually
Yeah.
obviously my lectures are mine.
Okay. Boss or doesn't matter. Just
The one. What if you just said he?
It's like, it's like a couple friends.
No, no.
Let's get quiet. Madison Andrews. Tyranny Ballard, did I say that right?
It's Tierney, yeah.
Okay. Uh-huh, I feel like I've said the names in a long time. Rachel Barrett. Emma Brown. Selena Costello. Adrian Davis. Shimo Franklin. Shimon. Hannah Gallagher. Emily Grace. Logan. Sierra. Erna. What's the name? Sammy Moore. Ross Quimby. Gianna Rose. Summer. Katie Stinson. Riley Troy. Miranda. Lanuski. Rachel. Did everyone get their exams back? The grades were really good. There were, when you combine the take home and the in class together, there were 13 A's, 2 B's, 3 C's, and 1 didn't come. How many people were in class? 20. 1 didn't come and 1, I couldn't open the take home part, so they're not on that. So if you don't, at the back of your in-class test, if you missed anything on the take home, it says what you missed. If there's nothing there, you either didn't miss any and got 50, or you're the one that I couldn't read. I couldn't open it, but you got an email saying that. So if you have no grade on your take home portion, that's why. But it probably converts to a 0 today. Any questions? You want to keep your exams because we'll use them to study for the final. So the last week of class, we'll go over anything that's on an exam that you'll need for the final. But if you have any questions on any, you could also ask. What happened? Oh no. How much did I take off? It was the end of the test and you were just, okay. Alex, last week you needed to do the check module 1 or whatever it's called. The catch-up module 1. And if it was at 100%, but your hours for the week was not, I put that in this morning. If it was at 50% and your hours were at 2%, I gave you the 50%. So whatever that was at, if the percent was lower, I gave you the higher percent. Week 6. For Alex, you should complete modules 6 and 7 by Sunday. And that's chapter 4, and half the class is half done, so, well, half done with the first module. So module 6 is at 50% already, which is great. I think when you did the module check, if you knew everything, then it started giving you stuff for chapter 4 and the stuff we had reviewed at the beginning of the week. So that was nice. There will be another assignment on Friday. Chapter 4 is probability. So I don't know how you would do it if you're not in class on Friday. But I made I just ordered it at Amazon. Colored, well, they're not marbles, they're discs, but they're different colored discs that you pull out of the bag and toss a coin and find in the different colors. That's something different. We talked a lot about this first page, but I don't think we went further than that. Right, I think that's where we stopped. So just a little quick recap. Probability experiment is a chance process that leads to a well-defined result called outcomes. Tossing a coin would have tossing a coin has 2 outcomes, heads and tails. Rolling a die, depending on the die, if it's a regular 6-sided die, it has 1, 2, 3, 4, 5, and 6 as the outcome. True and false question has true or false. Any questions on that? We talked about it. I forget, right before we started reviewing for the test. 3 basic interpretations of probability. One is classical probability, the type of probability that uses sample spaces to determine it. So if we were talking about tossing a coin 3 times, we would think of it sample space. When we toss it 1 time, we can get a head or a tail. Then the second coin, a head or tail. Or if we got a tail first, tail, and then 1 more time. But a tree diagram is a good way of finding all of your possibilities. Because then you just follow the tree. 1 possibility, a head, and a head. And there should be, if we're doing it 3 times, in each one, there's 2 outcomes, a head or a tail. 2 times 2 is 4 times. There should be 8 outcomes. So when you're doing more than one thing to find all the outcomes, you can look at each outcome separately, and then multiply. So we should get 8. Outcomes is one possibility. Heads, heads, heads. The sample space is when you list all of your possibilities. And there's 8 of them. Heads, heads, and a tail. Heads, tail, heads. Heads, tail, tail. So that's using all the possibilities with the heads. And then you do the tail one. Tail, heads, heads. Tail, heads, tail. Tail, tail, heads. And all tails. 8 outcomes. So on ones where you can't think of all the possibilities because you know there has to be 8 and you only have 6, a tree diagram will help. Any questions? Probability should be reduced. Okay. When you're finding probabilities, they need to be a reduced fraction, a decimal, or a percent. Let's see, probability should be expressed as a fraction or a rounded decimal. Okay. It's saying that when you have a probability that's a decimal, you should go 3 decimal places. So not one more than your data, 3 decimal places. So on Alex, if it doesn't say, and you're doing a probability, 3 decimal places. If it's extremely small, this one, then you just go to the first non-zero value and round it. So if you can't, like to get 3 decimals, it's this small, they will have you round it here. Did we do the probabilities also? No, I didn't. Yes or no?
I'll be doing.
We did do the short ones. I put the cards up, or did we only do how many possibilities are there? I think we.
I didn't write it down, so I
Okay.
don't know if we did.
Yeah, I think what we did was the number of outcomes. Well, we did do draw 1 card from a deck of cards. We'll go over it again because I know it causes problems. And you're finding a probability and you're writing it as a decimal, it should be between 0 and 1. Well, even the fraction should be between 0 and 1. If it's a percent, then it's going to be between 0 and 100. Probability of an event happening should be between 0 and 1. If you get something larger than 1, you're doing something wrong. If you get a negative, you're doing something wrong. If you add up all the probabilities in your sample space, they should add up to 1. If an event cannot occur, its probability is 0. So if we're rolling a 6-sided die, the probability of getting a 7, 0. If you have a standard deck of 52 cards, there's no jokers in it. The probability of a joker, 0. The probability an event is certain to happen is 1. So if we're rolling a 6-sided die, the probability that the number is greater than 0, it's definitely going to be greater than 0 because it's 1 through 6. So the probability is 1. Any questions on that? So if a probability can't happen, it's 0. Don't think I wrote something wrong. I want 0. Let's look at these probabilities. You want to get comfortable with a deck of cards? So if we want the probability of a red 6, when you're finding probability, it's your total amount in what you want. For instance, a red 6, there's 2 of them. So it's how many are in that event that you want, divided by the total possibilities, which is 52 cards. So the probability of a red 6 is 2 out of 52. But Alex is gonna mark that wrong because it's not reduced. So if they want the fraction, 2 will divide into the top and the bottom, which is 1 out of 3, 26. So if they wanted the fraction, it'd be 1 over 26. If they want the decimal, we would go 3 decimal places. 1, 2, 3. The 4 will leave that at an 8. Normally they'll want the fraction or the decimal, but if they want the percent, multiply it by 100. But usually they'll ask for either the decimal or the fraction. Any questions on that? Probability, it's a face card. How many face cards are there? Anyone? 3, 6, 9, 12. So we would reduce. Or the decimal. Point 2, 3. I don't remember. Well, it doesn't matter. On the test, When you're rounding here, this is a 4. So this goes and stays a 0. Don't think this 6 will make this a 5, which makes this a 1. Use the number that's there, see where you're going. Don't look at after it. You just go with the 4. It doesn't matter what's after it. Any questions on that? Ace. So probability it's an ace. How many aces are there? 1, 2, 3, 4. And they also on Alex, these are also ones. So if they said below 3, you'd be counting 1 and 2. So an ace is also a 1. There's 4 out of the 52, which is 1/13. Any questions on that one? I like not reducing my fractions simply because if we're doing a bunch of them, it's easier for me to grade. I don't have to, if you, on a test or a homework assignment, write it before you reduce it and then when you reduce it, because if you reduce it wrong, if I have the correct answer, I would not take off. So make sure you show this. Probability, what's the probability of a heart? 13. There's 13 hearts. It's the top row. These ones are called clubs. That, and the other one's called a spade. I don't know if I can draw that one as well. I can't draw a spade. And like that. But this one's a club, this is a spade. We're looking at the hearts, 13 out of 52, which will reduce to 1/4 or a quarter. Didn't choose red. Probability of the card is black. There's 26 of them, or half of them. 26 out of the 52 is 1. Or 0.5. Any questions so far? About 4s and 8. Go ahead and do the next 5. added one more after you do the probability of red or black. I want to know if that's the same as the probability of red and black. And you don't have to reduce it. And slip the A.
Yeah.
Okay, probability of a heart or a king. Getting 16, not 13, 14, yeah, 16 out of the 52. Because there's 13 hearts. But we already counted one of them, so then there's 3 kings. So you can't when they overlap, and we'll learn a formula for it because of that overlap. So when we do the hearts, we're including one of the 4 kings, so then there's only 3 more kings. Because we don't want to add it twice. 16 out of 52. A formula. The symbol you'll see for or is a U. And it means either one. Either, in this case, a heart or a king. The formula, when you have an or, is the probability of A plus the probability of B minus their overlap. So either way will get you the same answer. If you can think of the whole sample space and realize when you're adding the 13, you already added this one in, so there's only 3 more kings to get the 16. Or we could do it this way. A was heart. So the probability of a heart is 13 out of the 52. The probability of a king is 4 out of the 52. minus probability of a king and a heart. There's only one king that's a heart. So 1 out of the 52. Another reason why you don't want to reduce till the end if you are. 17 minus 1 is 16 out of 52. But if you can picture the image or have the cards once, it's easy to skip the formula.
Wait, where'd you get the 452 from?
Kings. So this one was the probability part. Plus this probability king minus the probability. Oh, I couldn't do any of them. That doesn't matter. Never mind. That one wouldn't overlap. I was trying to think of a decimal one. When we have decimals and probabilities without a sample space, you'll have to use this. And it comes up in a little bit. I did the probability of and 1 out of 52. The probability of the heart and a king, there's only one. For and, use this symbol. What's the probability of getting a card that's green? Are there any? There are on a roulette wheel, there's 2, but here there's none. Same thing with a joker. If you only have a standard deck of 52 cards, which this does not, if you notice there's no jokers, then the probability of a joker is 0. Any questions on those? So if you had a deck of 54 cards, which include jokers, then it'd be 2 out of 54. What's the probability of a red or a black card? Anyone? No. Red or black aren't, wouldn't that be all of them? Because when I pull a card, it's either going to be red or black. So or means it could be the one or the other. Red is all of these. Black is all of these. 52 out of 52. So if you have a standard deck of 52 cards, you're definitely pulling either a red or a black card. How about picking a card that's red and black? Can you do that? This is one where there's none of the cards are red and black. It's one or the other. So it's 0. Any questions on that? On the red or black, if we used this formula, the probability red plus the probability black minus the probability red and black. Probability of red, 26 out of the 52. Probability of Bellac is 26 out of the 52. The probability of getting both is 0. 52 out of 52 is we will get into a definition for when they don't overlap, but I don't want to get out of order. Any questions on the cards? Okay, the complement. Of an event is the set of outcomes in the sample space that are not among the outcomes in the event. For complement, they use an E with a line over it. And then it's 1 minus the probability it will happen. There's a few different ways. If we know what won't happen, we can find some probability it will happen. And then when you add those two events together, you should get 1 because one is it will happen, one is it won't. Combine them and you have your whole sample space. Probability it's not a red card. Well, if it's not a red, we could take its complement 1 minus the probability it is a red card. And this works nice when there's a lot in one probability and only 1 in the other part. And you just subtract it out. The probability of red we said was half, or 26 out of 52, which gives us 26 out of 52 that it's not red. There's a 30% chance of rain. What's the probability it won't rain? One minus its complement. .7 or 70%. When the weatherman says there's a 30% chance of rain, he doesn't mean that in all of that viewing area, you have a 30% chance of seeing rain. He actually means in that viewing area, 30% will get rain. So it just depends on if you're in the right spot or not. Any questions on the complement? Oh, I think I made it. Tossing 3 coins. Well, we did the second one. Tossing 3 coins, find the probability at least one is heads. Well, if we don't want to write all of them out, we could find out how many there are first, because each time we toss our coin, it's a head or a tail. 2 outcomes. which means, well, you could look back at the one we wrote, but there's 8 outcomes. Ability, at least one's heads. Well, if at least one of them is heads, that's every possibility except for all 3 tails, right? There's only one that wouldn't fit into at least one of them being heads. And you can look back at the sample space when we did the 3 heads, heads, tails, and so on. We could just subtract the 1. Because the only one that wouldn't be in at least one of them heads is if all 3 of them are tails. So it would be 1 minus the 1/8 or 7/8. So when there's a lot of possibilities in the answer you want, subtract the ones you don't. Any questions on that? Imperial probability is the type of probability that uses frequency distributions based on observations to determine numerical probabilities. It relies on actual experiences to determine the likelihood of outcomes. So we know a coin, the probability of heads is 1/2, but empirical would say toss that coin 100 times and see if you end up with 50 heads and 50 tails. So you're taking the frequency of the class divided by the total number of times you do it. Same thing we've been doing. It's just another way of wording it. Empirical just means that you're doing the experience. You're tossing the coin 100 times. AAA asked 50 people traveling over the holiday weekend how they were getting to the destination. And the answers are as follows. So driving is 41, flying is 6, train or bus is 3, add them up and get 50. The probability of selecting a person at random who is driving. What's the probability they're driving? Your frequency divided by your total. So 41 out of 50, 41 50ths. And I don't think that reduces. What the probability of not flying? Two ways we can do it. Not flying, we could add up the 41 that are driving and the 3 that are taking the bus and get 44 out of the 50. Or we could subtract out flying. So you could do 1 minus the probability they're flying. Flying was 6. $44 out of 50. On Alex, you would have to reduce that. I think only 2. 22 out of 4. Any questions on reading the table? You definitely want to be able to read contingency tables because it even goes into the next chapter after this. study done on the number of hours a person sleeps per night. Less than 6 hours is, out of the study of 100, is 12. 6 hours is 26. 7 hours is 30. More than 8 hours is 4. Wanted to get all of them up there. Find these probabilities. So go ahead and find those 4 probabilities using the table. Words can definitely trip you up. I always think of money. And that helps me think about the problem. I think it works easier, fewer than $7, at most $8. It helps you think of whether you should be including that value or not. Probability of 8 hours. So 8 hours is 28 out of 100 or 28%. I'm not worried about reducing fractions. So on the test, homework, anything you're turning into me, you do not have to reduce your fraction. If I see it unreduced, then I understand where your number came from. And if you put a 30 or added a couple together, I can see that. So don't reduce. Or if you're going to reduce, put this first. Okay, fewer than 7 hours. Fewer than 7, am I including the 7?
No.
No. If I have fewer than $7, I don't have 7, I have less than that. So we're not including the 7, we're including the 26 and the 12. $38 of 100 or 0.38, depending on what it asks for. At most 8 hours. Am I going 8 and above, 8 and below, or not including the 8? 8 and below? You agree? If I have at most $8, I have 8, but I don't have more than that. I have at most. So we're including the 8 and everything below. So we either have to add all of those up, or notice there's only one that's not included. So we could take 100 minus the 4. Or 1 minus 100. You have a calculator, you could add all of them up, but I don't want to have that in my head on a Monday morning. I would be better off subtracting the 4, which gave me 96 out of 100. So if you add these four up, they should come to 96. So when there's a lot of them, or to double check, you can always check that these two should add to 1. Okay, at least 7 hours. Am I going below or above the 7? Below again. And am I including the 7? Yes. So we're including the 7. 30 plus 26 plus 12, so 30, 40, 50, 68. If I added right. Any questions on those? Any questions on reading the table or the wording? I tried to pick the ones that were most questionable. I think you know less than or greater than. The law of large numbers is a law that says when a probability experiment is repeated a large number of times, the relative frequency probability of an outcome will approach its theoretical probability. If I toss a coin 10 times, I may get all heads. I know that I should have gotten 5 and 5, but either the coin's weighted or just got lucky. But if I do it 100 times, I should get closer to the regular or the real probability, which is half of them heads and half of them tails. So the law of large numbers tells you the more you do something, the more likely you will get to half and half, or depending on what it is. Rolling a die, they should each be 1/6, each number 1/6. There is. I forget who holds the record right now. Super Bowl 9 times. That's just Super Bowl. The Buffalo Bills are on a magical streak. I think they lost right after this came on. Oh, no, it is larger than that. I think it is 16 now. Okay, so they won 14 coin tosses in a row. What's the probability that they won 1 coin toss? Out of 2, because 1 was right and 1 was wrong. When they go to do the next coin toss, still 50-50 chance. Unlikely that they'll win again, but it's still 50-50 chance. When they go to toss the next coin, 50-50 chance that they're right. But if they won 10 wins in a row, what's the chance they're going to win another one? Not very likely. But what you do is you multiply each of those probabilities together. No, this says they won 14. I think someone won 16, but we'll go with the 14 wins. So we'd have 14 of these. which is a very small. Now we can take it to the 14th because we're multiplying 1/2 times 1/2 times 1/2. I should be at 6.1, but if you look all the way on the right, it has the e to the -5. What that means is we're going over 1, 2, 3, 4, 5. That's the probability of winning 14 coin tosses in a row. So when the first one happened, I think it was 11. I forget who, I think it was the Bears. Well, people started betting on it now. So once they start getting high enough, people bet more on that than who's going to win or lose. Because it's still 50-50 chance that you're going to get it right. Even though the likelihood of it coming out, it's not very likely that they're going to win again. Still 50-50 chance. Any questions on that? So the law of large numbers tells you the more you do something, the more it's going to get close to a 50-50. But here's a case where they did 14 in a row and it's still showing. And you know it's not one-sided because it's different games. Any questions on that? I think it's a neat problem. Oh. There's a CoinFox website. Toss. This is how many times. So if we toss it 10 times, now the other day, it was giving me everything the same. 50-50. It's not. All right, what if we do 50 times? There was another one that did it real fast and gave you the total, but it wasn't working. Now, see, they do have a lot more tails right now, but the more you do it, the closer and closer it's going to get to half and half. And now the heads is passing it up. But the more you do it, large numbers says the closer, more 50 we do, we should get 25 and 25. Although right now heads is ahead. Chances are, I think this is fixed. We'll see. But any questions on large numbers? So the more I toss it, the more I should get 50-50. Oh, we didn't. We got 2 heads more than tails. You do 100, you get closer and closer. Any questions? That's what large numbers teach. Another type of probability is called subjective probability. It's a type of probability that uses a probability value based on an educated guess or estimate, employing opinions and inexact information. A sports writer, based on his experience, might say the Browns have a 30% chance of beating the Steelers. He's wrong because they did win, but he might use an educated guess. Doctor might say 25% chance you might need surgery. Looking at the statistics that you have from things I've seen before, there's a chance. So it's just an educated guess. You watch the teams, you see One has a lower winning streak than another, or lost two different players, then you can make an educated guess. Any questions on that? Is there any questions on what we've covered so far? Like, do you want to see more problems?
Yeah.
No. Was that a yes or a no?
Yeah.
Yeah, more, okay. There's a lot of good problems at the end of each book, each section. Assume you're at a carnival and decide to play one of the games. You spot a table where a person is flipping a coin, and since you have an understanding of basic probability, you believe that the odds of winning are in your favor. When you get to the table, you find out that all you have to do is guess which side the coin will be facing after it's tossed. You're assured that the coin is a fair coin, meaning that the two sides are equally likely. You think back about what you learned in your stats class about probability before you decide what to bet on. Answer the following questions. What is the sample space? Anyone? You're tossing a coin. Sample space are all the possible outcomes. If you're tossing a coin once, what's the possible outcomes? Heads or tails. So your sample space, heads or tails. The possible outcomes is the sample space. What does the classical approach? Now, on a test, I'm not going to ask you classical approach and everything. Classical approach tells you 50% chance. You decide to bet on heads, believing that it's a 50 chance of coming up. A friend of yours who had been playing the game for a while before you got there tells you that heads has come up the last 9 times in a row. Well, you remember the law of large numbers. The law of large numbers, which we just talked about. Would that change your mind? If heads came up 9 times in a row, knowing that eventually it's got to be a tail, the more you get that, the less likely it is to happen again. Or maybe it's a fixed point and you should pick heads. But that's what it's getting you to think about. So a question like that, I would be making sure you understood what large numbers means. Chances are the next one's going to be a tail, but it's still a 50-50 chance, unless it's a weighted coin. The empirical approach to probability is based on running an experiment and looking at the results. But you can't do that unless you just stand back and let other people play it and then see what's happening, then make your bet. Can subjective probabilities be used? Yeah, you could be subjective because your friend said heads came up 9 times in a row. Probably going to come up again. You, assuming it's a fair coin, doesn't matter which one you pick. But knowing all those different probabilities can make you think different ways. I think we're okay with definitions. What is a probability experiment? It's something that's by chance. Sample space is the list of all possible outcomes. An outcome is just one possibility. An event is what you're looking for the probability of. The difference between an outcome and an event. An outcome is the result of a single trial probability experiment. But an event can consist of more than one. So if we're tossing a coin 3 times, probability of all heads is one outcome, but it could also be the event. Or the event could be more than one with the one, what did we do? Probability, at least one head. So an outcome is one thing, one possibility that you could get. An event is, it could be more than one, but it could be one. The event is what you're looking for the probability of. Equal likely events have the same probability of occurring. When you toss a die, each number equally likely. What is the probability of rolling a 5 on a 6-sided die? 1/6. The probability of rolling any one of those numbers is 1/6. So they're all equally likely. Of the range of values for probabilities between 0 and 1. If an event is certain to occur, what's its probability? Anyone? Let's do the probability. If the probability that it will rain tomorrow is 0.2, what's the probability it won't rain? Anyone? 0.8. A probability experiment is conducted. Which of these is considered a probability outcome? I know this is on, I saw this on Alex. To be a possible outcome, it has to be between 0 and 1. Unless it's a percent, then it's between 0 and 100. So 2/3, that's between 0 and 1. 0.63 between 0 and 1. This one's negative, so C cannot. This is greater than 1, so it cannot. So far C and D and E, because it's a negative. You can have 0, you can have 1, but you can't have over 100%. So H is no good, but I is. So C, D, E, and H. So it has to stay between 0 and 1. Unless it's a percent, it can go up to 100. I'm not worried about that. Okay. Rolling a die. If a die is rolled one time, find the possibilities. What's the probability of getting a 7 if you roll? I would assume that's a 6-sided die. Remember the sample space is 1 through 6. What's the probability of getting a 7? 0. 0. How about the probability of getting an odd number? 3 out of the 6. And they're probably going to reduce it to 1/2, but 3/6, 1/2. How about the probability of getting a number less than 7? 2. 6 out of 6 or 1. How about getting a prime? Oh, they put them. Prime number. So prime number is a number that's divisible only by 1 in itself, but 1 is not prime. So on a 6-sided die, it's 2, 3, and 5. Which would then be 3 out of 6 or 1/2. Any questions on the die ones? How about this one? Getting a number greater than, oh, it said greater than 2. Greater than 2 and even 2. So we want greater than 2, which means we're only using these numbers, and even 2 out of the 6. Or 1/3. So be careful on the wording, and has to include both, or would have been 5 out of the 6. Two die is used a lot. If we roll 2 die, the possible outcomes, rolling 1 has 6, rolling the second one has 6. There's 36 outcomes. You have to be careful. Notice that there's a 3 and a 1 here. And there should be a 1 and a 3 here. So the 2 different dies, you want to think of them as 2 different ties so that you can find all 36. That was the first part. A sum of 5. So we want to be able to add the 2 die up and see what they add up to 5. So this one would be 5. So there's 1. That one's 5. That one's 5. 4 of them. These are all too large. So there's 4 out of the 36. And then you could reduce. Find the probability the sum is 9 or 10. Getting 7. Here's a 9 and a 10. So 2, then it moves down 4, goes down 6, and 1 more, 7. So you would want to think of all those possibilities. Any questions on that? Now, if you didn't have the sample space to get a 9, you can think of 4 and 5, 5 and 4, 3 and 6, 6 and 3. And that's all. 10, there's a 5 and a 5, a 6 and a 4, and a 4 and a 6. So you can think of all the cases where 1 through 6 and 1 through 6 added together give you 9 or 10. What's the probability of getting doubles? How many doubles are out there? 6?
Well,
No, because it's the same thing. Like if we get a 1 and a 1, it's still a 1 and a 1. So it's only one possibility for each. So there's only 6 doubles. Has anyone ever played craps? The 7 is the one, I think you lose if you get a 7. Well, that's because it has the biggest probability. The sum of being 7 has the most. Because there's a 7 here, there's a 7 in every row, I think. 7, 7, 7, 7, 7. It has the highest possibility. Any questions on the 2 dot? Oh, we've done a ton of cards. Okay. A shopping mall has set up a promotion as follows. With any mall purchase of $50 or more, the customer gets to spin the wheel shown here. If a number 1 comes up, the customer wins $10. If the number 2 comes up, the customer wins $5. And if the number 3 comes up, 3 or 4, the customer wins a discount coupon. Find the following probabilities. What is the probability the customer wins $10? For $10, they need to roll a 1. Kind of, they say how many?
It's 2 out of 20, it's 20. It's 20. 2, 6, 7, 8, 10,
16, 17, 18, 19. So there's 20 spots on the wheel. And there's only 2 that are 1, so 2 out of 20. Or reduced. Oh, they use the decimal. What is the probability the customer wins money? So to win money, $10, so a 1 and a 2, you win money. Getting, is there 4 of them? 1, 2, 3, 4. What is the probability they win a coupon? Coupon was 3 or 4.
Yes.
Now remember, we could do 1 minus the probability they won money, 0.8. I will not ask you this. My son, I think it was 4th grade, and the teacher did some probability stuff and asked a question like this, and he said, by the time I sing the song to get to the M's, the test is gonna be over. Because he didn't memorize all his states and their letters. He knew by the song, Alabama, Arkansas. I don't know the song, but there's a song they learned for the letters of or all the states in alphabetical order. But to get to an M would take too long. So I will not ask. Blood types. Probability, let's do this one. And yeah, I like this because it has numbers. We haven't done a lot of numbers. So the probability your blood type is O is 43%, A is 40%, B is 12, and AB is 5. And if they're listing everything, it should add up to 100%. Choose one American at random and find the probability that he has blood type B. What's the probability they have blood type B? 12%, 4.12, either way, depending, let's see what they wanted. 12%. So on Alex, usually in the fine print below, it'll say, write your answer as a decimal, write it as a percent. What's the probability they have type A, B, or O? O is 48%. We just add them together because it's an or. We don't have to worry about subtracting the overlap because you can't have an overlap. You're either one type or another. And so we would add the 43 and the 5 and get 48. Does not have type O blood. Add the 3 that do, or take 100 minus the 43. Any questions on that? World speed limits for all 50 states are indicated below. 60, 65, 70, and 75. Choose one state at random. Find the probability it's 60 or 70 miles per hour. $60 or 70 would be 18 and 1 would be 19 out of the 50. I don't know how they want. 0.38. So 19 divided by 50 will get you the decimal. What?
560 miles is one, and this, and this is.
So what?
There's only 50 there.
No, I meant the letters.
Oh. Greater than 65. Would greater than 65 include the 65? No. So it would be 18 plus 13 divided by 50, get 62. 70 miles per hour or less. Would that include the 70? So it'd be everything but the 13. Dividing by 50, you get 70. Any questions on those? We won't do all this probability, but I want to know, a couple has 4 children, and if you're going to list boys and girls, how big is the sample space? How many are in the sample space? Think about the possibilities and how we did the heads and tails. How many would there be? Okay. We're doing 4. Each one has, when you have your child, there's how many possibilities? 2. And we have another one, it's still a boy or a girl. So to list the sample space would be 16. I wouldn't make you do, but I might ask how many there are. So there's 16 different possibilities. If you did have to do that on Alex, a tree will help you get all of them like we did the tossing the coin. But it's the same similar probabilities. And I do recommend writing the whole sample space if you do have questions like this. It's easier to count them. Is there any more questions on probabilities? So 4.2, some of this we've talked about already, addition rules. Finding the probability of more than one thing, and we've already done some of it, like a heart and a king, or a heart or king. Well, what you need to look at is if they're mutually exclusive events. Mutually exclusive events cannot occur at the same time. One thing we had looked at was the probability of pulling a red and a black, or a red or black. Those two things don't happen at the same time. They're mutually exclusive. Getting a face card and getting a 6, they're mutually exclusive. You can't get both if you're only pulling one card. A face card and a heart, those have an overlap, right? Because there's face cards that are hearts. So the first one is mutually exclusive. But the second one, there's an overlap. So they are not disjoint. They'll use both terms intermittently. So pulling a face card and getting a heart is not mutually exclusive. How about getting a 7 and a king? Can we get both in one pull? No. So that means that's mutually exclusive. They have nothing in common. How about a queen and a spade? There is a queen that is a spade. So there is a possibility. So they are not mutually exclusive. Whoops, not mutually exclusive. So the yes means they are. There's this plastic covering on this and it's not user friendly. Any questions on the difference between the two? So if they can overlap, not mutually exclusive, a face card and a heart, there are 3 face cards that have hearts. So they're not mutually exclusive. They have an overlap. Any questions on that? When 2 hands, A and B, are mutually exclusive, the probability of A or B, and notice I put the union in this one, is A plus B. So the formula I gave you with the minus, that was because of the overlap. Now, if you always want to use that, sometimes the overlap's a 0. The overlap is a 0 when they're mutually exclusive. So if something is mutually exclusive, the probability of A and B is 0. So if they're mutually exclusive, then you can just take the probability of each and add them together because there's no overlap. AAA asked 50 people traveling over the holiday weekend how they were going to get to their destination. These are not an overlap. You're either going by driving, flying, a bus, train. There's no overlap. So the probability that they drive or fly, we could take the probability of driving and add the probability of flying together. Because they're mutually exclusive. If people were asked favorite type of movie, and these percents were given, the probability of a person is chosen at random and likes drama or romance. Well, you can't like both because you had to pick one or the other when you surveyed it. So there's no overlap. You would just add the percents together. Drama and romance, 5 and 30 is 35%. So as long as there's no overlap, pie charts, bar graphs, there's some contingency tables that will have overlap, but that one doesn't. Any questions on that? Okay. Second rule, when they are not mutually exclusive, when there is an overlap, this is what I gave you earlier today. You add the two together, but then you have to subtract their overlap. The book talk, and I don't know if they'll make you do a Venn diagram. A Venn diagram where they are mutually exclusive. They do not overlap. If they're not exclusive, there's going to be an overlap. They have a part in common. So if they do show you a Venn diagram using it, if there's no overlap, they're mutually exclusive. If they do overlap, they're not mutually exclusive. We did do that one already, but probability heart or face. Probability of heart or face card. So we know the hearts are all of these, but 3 of them are also face cards. So if we do the probability of a heart, that's 13. The probability of a face card, 3, 6, 9, 12. Minus a heart that's a face card, that's 3. Because we counted this going across, but then we counted it going up, you need to subtract those out. Or count the 13, 14, 15, 16, 17, 18, 19, 20, 21, 22 out of the 52. But when you don't have that image or they're only giving you probabilities, you need to know the formula. Any questions on that? Okay, the probability of a female or a cat. Now, when we have a contingency table like this, some of them don't have totals. If they don't, write it on your paper and put those totals in. Because you need these totals for a lot of the probabilities we're going to do. So we want the probability it's a female or a cat. Probability of female is 48. Forty-eight over 100. So if you go across, the probability, the total for female is 48 out of the 100. Cat is a column, so this column going down. And there's 49 cat out of 100. And then we subtract our overlap because when we went down and we went across, we did the 39 twice. Because, wait, is it male? That's female. 39, we did twice. We went across and added it, we went down and added it. So you have to subtract out the overlap. Any questions on that? Definitely don't reduce these until the end. I guess if you're plugging it all on your calculator, it doesn't. Any questions on that? Okay. I think that's it. Yeah, we've covered 4.1 and 4.2, which is the first module, I think it's module 7. And then the rest of it's in the next one.
Yeah.